Alright, another draft physics video presentation. This one on magnetism, simply titled. A guy called Matt Anderson does this interesting technology. He has this screen and I like it. Yeah, I want one. So anyway, so he's going to make the same argument that all the physicists make. There's no magnetic monopoles, and the logic I'm just going to show is how poor it is, and then I'll speculate on a few things that have just occurred to me, and such. So draft part at the end, very draft. Not entirely sure that's how it works, but I'm going to throw it out there.
Doing that all the way down until you get to essentially nothing.
Okay, here we go. Start
all
over.
Familiar with this?
All right, all familiar with this bar magnet. I don't know why it's not very loud, but anyway, I guess that's because he's talking through a screen.
So, let's say we take that bar magnet and we cut it in half. Okay, so I'm going to cut the thing in half. Right there.
So the argument would be made if I did this with charges. If I took a negatively charged sphere and I cut it in half, I still get two negative spheres. But with a magnet, it's a dipole. If I cut it in half, I don't get a dipole. Now, if I do take two charges and I actually do bring them in proximity to each other and then separate them, let me just think how that works. Do I have to have them in contact? Yeah, so I have them in contact, and then I polarize one side, make it negative. The other side becomes positive. And if I break that apart, one will stay positive and one will stay negative. So charge does function the same way, but you have to just think about it a little deeper. And it's like they're just doing this trivial thing. See, magnets are fundamentally different. When they're not fundamentally different. They're different, but not fundamentally different.
And if I do that, that south pole is down there, the north pole is up there. Is that it? Is that all that happens? The answer is no. You in fact develop two new magnets.
Right. Now, even their understanding of that is kind of obvious, in the sense that they won't disagree that the idea is because the magnet is made of a bunch of little magnets, okay, all pointing in the same direction. I mean, domains and iron and all that kind of stuff. So these would all be north-south magnets. I guess I could just color one end and you get the idea. And they're all oriented in the same direction, and collectively that makes a big magnet. That would be like this. So they're obviously doing the same thing as little bits that they end up doing collectively, and it's just a magnified effect. The little bit of magnetism is added to a little bit of magnetism is added to a little bit of a magnetism, and so you get 3x magnetism out by stacking the magnets. So you can do this with physical magnets. You can stack a bunch of little magnets on top of each other and end up with a stronger magnet, as the collection of these magnets. So there's no mystery that the reason why when you're breaking the magnet, you're not breaking this middle magnet in half. No, you're taking, and when you break it, what you're going to break is in between the magnets. And so, yeah, you're going to end up with a north end and a south end. And you're going to end up with a south end and a north end. Because you're not breaking a physical magnet in half. You're just like if I was to separate these four magnets I stacked, if I was to separate them, they're going to break here. Okay? They're not going to break in between one of the magnets. So, I mean, it's kind of obvious. This will probably be better. All right. We'll play some more. Hey, we don't need that. Thank you.
Both of those have a north pole and a south pole. And now if you do it again, and I cut this little piece and that little piece, I cut them in half again, each one has a north pole and a south pole. Okay, north and south, and so on.
So he's sort of doing this like baby talk thing, like saying, "Oh, look how simple it is. Look how obvious it is." You know, I keep breaking the magnets and they keep making new magnets. You know, but like I said, they know better. They know that it's atoms. The fact that the atoms are becoming polarized, that creates the element of the magnet. It's the dipole of the atom, okay, that's making the magnet. So this part is just, you know, this makes no sense.
Okay, and you can keep doing that all the way down until you get to essentially nothing.
So does that make any sense? You can do that all the way down until you get essentially nothing. When they know that the iron or some other element is magnetic because the atom itself, okay, has a slight polar imbalance, and that all you're really doing is taking a bunch of atoms that are scattered in all directions, okay, and when they're scattered in all directions, you lose their dipolarity. It doesn't add up. This cancels a piece of that, and this one cancels a piece of this, this one cancels a piece of that. They end up just canceling each other's polarity. And what happens in the iron is that, no, that's not what happens. I mean, I put it in a magnetic field, and what's going to happen is all the atoms are going to start doing this kind of thing. They're all going to start arranging in the same north-south orientation, and this is going to be multiplied times that, and this times that, and this times that, or plus, however you want to do it, plus, plus, plus. The magnetic effect is going to magnify, okay, by orienting all the atoms the right way. Now they're not canceling each other. Now they're all complementing each other. And that's what's making the substance magnetic, is that you're aligning the magnets. You're aligning the little magnets and taking the chaos out of their magnetic fields that they're creating, and now orienting all the fields in the same direction. They know that's the truth. They know that if I keep making the magnet smaller and smaller, that eventually I'll get to the atom, and they know that the atom is proton, electron. Okay, they know that. They know that's the origin of the magnetism. They know that's where you go all the way down, you get to nothing. This isn't nothing. The atom isn't nothing. This is clearly the monopole, negative. This is clearly the monopole, positive. So why do they keep saying this? It's nonsense.
And at no point do you get just a North Pole or just a South Pole.
So you're saying at no point, when you clearly know, of course you get to a North Pole and a South Pole. You get to charge. Charge is the basic elemental function. That's what makes a magnet, is two charges very close to each other. Now, we can't take two electrical charges and put them very close to each other because, especially in atmosphere, because they'll discharge. Okay, but theoretically you could in space put them very, very close together, because space is a completely imperfect conductor, so you could have them very close together. And if I made a negative balloon and a positive balloon, and I put them very close to each other, and then I made another dipole, you know, two balloons with the same charge, okay, and they're right just a millimeter distance apart, and I make another set of balloons. You probably can't see that. Yeah, can't. All right, make another set of balloons over here doing the same thing, okay, negative, positive. Then I could make them repel, and I could make this set of balloons, I could probably make it actually flip, you know, okay. This will flip, and then they'll stick to each other just like magnets. They'll behave exactly like a magnet. So why are they saying this stuff? Why are they saying this is the great mystery of physics? There's no magnetic monopoles. If you can find one, you get a Nobel Prize. All this nonsense, when it's clear what the monopoles are. The same monopoles of charge are the same monopoles of magnetism. How can you possibly say there's no such thing? And they only say it because Maxwell said it. Maxwell didn't even know what an electron was. He didn't even know these things existed. So of course he didn't understand there was monopoles, because he didn't know these things existed. He only knew that something existed, and he called it electricity, okay? And so he said there's electrical monopoles because he could imagine charge being very small, but he couldn't imagine a dipole being very small. He couldn't imagine any elemental dipole because he didn't have a model of the atom. But they do. So of course they understand, yes, electrons. That's the north monopole and it's the minus monopole. Yeah, well, I need more viewing space. I should have done this. But you get it. I mean, nobody can defend this intelligently. There's no intelligent defense for this nonsense that there's no magnetic monopole, that there's no origin or source, an obvious source to magnetism. The obvious source is the polarity of atoms.
And this is the statement: there are no magnetic monopoles. Okay? You can't have just a North Pole. You can't have just a South Pole.
Of course you can. Of course they're built right into the atom. It's why the atoms become magnetic, is because their electrons are on one side and the protons on the other side, and that's exactly why it becomes magnetic, exactly why it behaves like a magnet. It's because of the orientation of protons to electrons. They're quite obviously the elemental monopoles. The fact that we can't physically build a giant electron, okay, something that is charged on the inside and the outside, and a giant proton, something that has charge on the inside and the outside, right? We can only put charge on the surface of things. We can't make something that is elementally charged. We can't make a giant electron and we can't make a giant proton. But that doesn't mean we can't understand that the atoms are doing it all the time.
Anytime you have a North Pole, you automatically have a South Pole.
Right, it's again nonsense, and you can see it. The electron is repelled by the north side of the magnet. The proton is repelled by the south side. The electron is attracted to the south side. The proton is attracted to the north side. It is quite obvious what the magnet is made out of.
Okay? North and South always come together.
So again, that's like saying electrons always have to be part of atoms and protons always have to be part of atoms. They always have to be polar and equal and all of that stuff. And of course they don't. And that's why there exist ions, and that's why there exist materials that become magnetic. It's because they don't always come in equal proportions. I don't know why
And this is very
all this
different
down.
than charge.
So it's no different from charge. It's only different in the sense that magnetism is an expression of what the material itself is doing. Charge in our world is only something that you put on the surface of something. That's the difference. Hello? Oh dear, the electric utility is apologizing. Yeah, I'm sure. I'm sure you're going to send me a rebate check. I'm sure you are. I don't have an electric utility in my name. So, sorry. No chance that was legitimate. You know, I would have hit the speaker button, but the buttons aren't working on the phone.
Talked about charge, you can have a positive charge sitting all by itself, a proton.
So again, yeah, a proton, exactly, just like the negative and positive of magnetism, the inverse relationship. It's exactly the same function. Again, just make your charge dipoles and see what they do. I mean, it'll do exactly what magnets do. It's exactly the same function.
You can have an electron sitting all by itself. But you can't have a North Pole just sitting all by itself.
No, I'm just saying. So when they look at an atom, what do they think? They look at a metallic, a magnetic atom. What do they see? What do they argue? They argue that that's the whole reason why it works, is because there's a polar sides. There's a unevenness, an imbalance. One side is more positive, one side is less positive or more negative. Fact.
The South Pole sitting all by itself. Now, there is a little bit of a caveat, which Professor Dalakashvili alluded to. There are theories.
I don't know Professor Dashkili. I've heard that before, but I guess that's the guy who wrote whatever wacky book this guy's talking out of.
That magnetic monopoles should exist.
They obviously exist. They exist in the same elemental, rudimentary, fundamental form as charge. It's exactly the same thing. Magnetism is about dipoles, and dipoles magnifying each other's effect, and charge is about what something is, as what it radiates, what reflects off of it. So the magnet has two opposite reflective sides. One side's reflecting proton force, one side's reflecting electron force, quite obviously, I think. and the inverse, when the inverse force hits them, it transmits it to the other direction. So proton force ends up proton force coming into the bottom proton side gets reflected, electron force gets sent to the north end, and so they just magnify each other's effects, and it's just the same as charge, except when they're smashed together, they become a conduit for tunneling or passing the force through them, transmitting it. And that's it. This is not even close to complicated. I mean, the clear point that he can't make this argument that no matter how small I cut the material, I'll never get to the monopoles, when clearly if you cut the atom in half, you have the monopoles of magnetism. We let him go a little bit more, but
that there should be a North Pole all by itself, and there should be a South Pole all by itself. But currently, there has been no experimental proof that those exist. Okay?
You don't even need experimental proof. You just need logic. Plain, simple logic. It's an atomic function. The only thing in the atoms that are doing this repulsion and attraction thing are the electrons and the protons, and it clearly fits. Again, if I make a charged dipole, it will behave exactly like a magnet.
And so this is the current understanding of the universe, but 10 years from now, 50 years from now, this may no longer be true.
And it won't be true because you find some magical new thing to call a monopole. It will not be true because you'll realize the plainly obvious, and a statement that you can just tell from your own broken logic, this broken statement of saying I can't cut the magnet any finer. When you get to an atom and you cut it, and you'll see, yeah, north end, south end. Now I can pull them apart. Electron, proton. It's plainly obvious. And people will defend this physics as being logical. You just saw him do it. He stopped right here. Oh, look, I make magnets this size, and if I cut them any smaller, they turn into like oatmeal or something. I can't recognize a positive and a negative. I can't recognize a north and a south anymore. When of course you can. You cut the atom in half, what do you get? Electron, proton. Alright, that's enough. I'll play a little bit more, but point made.
Physics, like any science, is an evolving field.
You're not evolving. That's the whole point. You're draconianly tell me I have to believe based on tiny shreds of evidence. A little tiny bit of redshift, you'll say the universe is expanding. A tiny bit of diffraction, you'll say it's Copenhagen. No, wait a minute. No, it's many universes. A new universe is being created every second. You're not subject to any kind of evolution or what's the word they use for when you have to defend what you're saying? Checks and balances or whatever. No scrutiny. No, you're not subject to any of that. You just draconianly say. Feynman says, you do the math. you make these rules that, oh no, none of this theory can be complete made up crap. You're arguing that somehow you have a ton of evidence and you've confirmed it. And then if somebody asks you, well, why haven't you done the detector experiment? You don't explain why. You keep saying you did it, something you never did. And then, and then you say, well, you never repeat the editing experiment. And then you just contrive a bunch of other experiments and say, well, this one's just like it, even though it's nothing like it. And then you ask, well, why you got 1 million satellites up there? Well, 50,000 with cameras on them. Why can't you just point one of those cameras for a few minutes towards a little bit towards the sun, and you can look at the nice big black field of stars right next to the sun, and why don't you show me how the light's being bent? You don't have any answers, rational answers. So you're just preaching out of your Bible, and you're saying anybody who differs off your argument is some sort of fact denier and science denier and all this kind of crap, when you're the one sitting on a pile of almost nothing as evidence. I mean, your evidence is a thin film full of distortion. It's nothing. You haven't earned this authority to tell somebody they're a kook or a science denier because they inform you that your evidence is pathetically weak. All right, enough. Let me have one more sentence.
Okay, we are continually evolving our models of the universe, and this is the...
You're not involving any foundational element you will not let anybody argue with. You'll make this draconian statement. There's no magnetic monopoles. You get a Nobel Prize if you find them. They're impossible. No one's ever been able to find them. Because you don't know where to look. Like in the obvious place. You're basically saying to me there's no tires on trucks. And I'm sitting there looking at them saying there's tires on the truck. What are you saying? Because the tires are bigger, they're not tires anymore? What's your reasoning? How can you deny that there's tires on the damn fucking truck? How can you deny that the fundamental elemental function of magnetism is created by polarized atoms?
Current understanding. But 10 years from now, 50 years from now, maybe in your lifetime, maybe they'll say, aha, there are magnetic monopoles. We found them definitively.
Yeah, they aren't hard to find. I mean, they're sitting there right in front of you. The tires are sitting there right there in front of you on the truck. And you're playing some semantic bullshit game because some guy 150 years ago said there's no tires on trucks. You're just still saying there's no tires on trucks.
And here they are. Okay? All right. What do these magnets do?
All right, well, enough of this because you have to speed it. It does talk a little bit too slowly. But anyway, it is a nice presentation, like it, cool, all that kind of stuff. But it's just, I mean, this is trivial and catastrophically flawed. I mean, here he is doing something that should be solid. You should be able to make this argument solid. And it's such a mushy, silly argument. Well, I cut them in half, and eventually there's nothing to cut in half. It all just disappears, and I didn't find any kind of monopole. I mean, anybody who has any integrity, any intellectual integrity, has to concede that this is one of the dumbest things physics is doing, is pretending they can't find a magnetic monopole. I mean, this is just ludicrously silly mush. All right, I can't, again, all I can do is reason with you retards. So I point it out to me. Show me how there's some flaw in my logic. Do you really think electrons and protons aren't creating the magnetism? Do you really think it's coming from somewhere else? Shit. All right. So, till next time.